Hi, today I'm going to discuss about two sample tests of hypothesis, and this is for discussion of advanced statistics class of business school in UPH Medan campus. So the goals of this class is we are going to conduct a test of hypothesis about the differences between two independent population mean, and this is going to be the continuation of what we have left before, which is discussing about the one sample hypothesis test. And then also, beside of means, we are going to conduct a test of hypothesis about the differences between two population proportions, and then also about the mean difference between paired or dependent observation, and understand the difference between dependent and independent samples. So those are going to be split into two meetings, and today we are going to discuss about the compare of means between two population. Okay, let's take a look at examples. If we want to understand what is actually two population comparison will be, maybe you will come up with a situation where you have a questions. Is there a difference between the mean value of a certain group and opposite to other group? For example, in this case, is there a difference in the mean value of residential real estate sold by male agent and female agent in the South Florida? And then, is there a difference in the mean number of defect product that is being produced on the day and the afternoon shift at Kimball Products, for example? So when you want to know, is it going to be differences between morning shift and afternoon shift? And if you have differences, then later you can follow up. And then also maybe some questions like, is there any difference in the mean number of days absent between young worker and older worker in a certain industry, which is fast food, for example? So we want to know which one is much better in serving the customer. And then also maybe you have a question, and this is question that related to proportion. Is there any difference in the proportion of Ohio State University graduates and University of Cincinnati graduates that both are passed the state certified public accountant examination on their first attempt? So these kind of questions usually are going to be common questions, especially when we are going to conduct research in in a management, in the hospitality, in the accounting, and then on the business aspect. When we are comparing the two population mean, no assumption about the shape of the population are required. So the population can be in any shape, and the sample supposed to be independent and separated, and then the formula for computing of the value of z is going to use these equations. So whether the sigma is known or unknown, we are going to calculate using z distribution. Okay, let's take a look at example. There is a supermarket, and this supermarket will install a U-scan facility. And the store manager would like to know if the mean checkout time using the standard checkout method is longer than using the U-scan. She gathered the following information, and the time is measured from when the customer entered the line until their bags are in the cart. Hence, the time includes both waiting in line and checking out. So we follow the 5 steps. We can conclude that H null is mu of the standard is actually smaller or equal to the mu of the U-scan. So we assume, the data of the population is being assumed that actually there is no differences, but in this case, it's considered as longer, and the hypothesis alternative is that mu of the standard is considered as longer than mu of the U-scan. Okay, so we already have the null and alternative hypothesis. Now we continue with the state of the level of significance. In the problem, it is being stated that the significant level is 0.01. And we find the appropriate test statistic, remember, because this is in the type of two population mean that is actually independent, yeah, we can assume that we are going to use this distribution. And also because both of the sample are more than 30. So this is the picture of how we can draw the situation. This is one tail, and one tail in the region of rejection is 0.01, which is the Z critical is 2.33. And we have to state the decision rule. We can write down that we are going to reject H null if Z count is larger than Z critical. And it means that Z must be larger than 2.33 if we are going to reject H null. Okay, so this is the result of the table from the data of both of the customer. Yeah, the customer type of standard sample mean is 5.5 minutes, the population standard deviation is 0.4, and sample size is 50. Yeah, so the U-scan is independent. They have different number of sample, which is 100, and the result also different. So from this we can conclude, we can calculate the Z using the equation, the formula, and we can find out that the Z is 3.13. The compute value of 3.13 is larger than the critical value of 2.33. Yeah, so we have like this. Yeah, this is 2.33, and then we have 3.13. This is the Z count. This is the Z critical. Yeah, so we have that number. Okay, now let's take a look at two sample tests about proportion. When we talk about proportion, there are some examples that we need to understand. Yeah, for example, the vice president of human resource wish to know whether there is a difference in the proportion of hourly employees who miss more than 5 days of work per year at the Atlanta and the Houston plants. Yeah, so there is two factories that is being owned by this vice president, and they want to know, what is the difference between the proportion between both of the plants. Yeah, so those we can use the two sample tests about proportion. Another example is General Motor. General Motor is considering a new design for the Pontiac. Pontiac is a automobile, the car. The design is shown to a group of potential buyer, and they want to see the difference between under 30 years and above 60 years. Yeah, so this separation, they want to know which one is of the group who like the new design, and then is there any differences among those group. This also can be used in marketing. Another example is a consultant in the airline industry investigating the fear of flying among adults. Specifically, the company wishes to know whether there is a difference in the proportion of men and women who are fearful of flying, for example. So in this case, we don't have the real data of details, but we can assume their proportion between binomial condition, yes or no, and so on. Okay, now let's take a look how we can calculate. We investigate whether two samples come from population with an equal proportion of successes. So therefore, the two samples are pooled using the following formula. So we believe that the proportion of the both samples supposed to be sharing equal proportion. Yeah. So to have those number, we have to make them full pooled proportion. So this is the calculation that we can do. Yeah. So pooled proportion equal to x1 plus x2 divided by n1 plus n2. Yeah. And then also after that we still follow the normal distribution. Yeah. And we can make assumption about whether it's going to be one tail or two tail, or one tail or two tail, and then we can calculate using z. Yeah, and but we have to input the pooled proportion into the z standard error. Yeah. So these are the equation. Okay, let's take a look at examples. Yeah. There is a Manelli perfume company recently developed a new fragrance that it plans to market under the name Heavenly. So they have a new product. Yeah. A number of market studies indicate that Heavenly has a very good market potential. And the sales department is particularly interested, yeah, in whether there is a difference in the proportion between younger and older women who would purchase Heavenly if they were marketed. So before this product is being launched, they want to know which one is having interest, yeah, in the product. Is it going to be younger or older? And there are two independent population, and then a population consisting of the younger woman and a population consisting of the older woman. Each sample woman will be asked to smell Heavenly and indicate whether she liked the fragrance well enough to purchase a bottle. Yeah, so you can see also in this case both of the population is actually independent. Yeah, although they are grouped into a similar or stratified. Yeah. Okay, we put into the step 1. Yeah, state the null and alternate hypothesis. H null is the P of 1 equal to P of 2. So we assume that both of the proportion of younger and older actually will have similar number. Yeah. So that is the population parameter. But also we claim that actually there will be differences, but we don't know yet. The differences will be either toward the older or the younger woman. So therefore we use questions, equality. Yeah. So we are going to use two tail in order to understand this. Yeah. And then we state the level of significance, which is 0.05, and find the appropriate test statistic. Because we are going to use proportion, in this case we are going to use z distribution. Yeah. So we can find out that actually, because this is 95%, we have minus 1.96 in the left, 1.96 on the right, and in this area, yeah, H null is going to be rejected. Yeah, with the hypothesis that P1 will be not equal to P2. And now we can state the decision rules. We are going to reject H null if Z count is larger than Z critical. In this case, Z critical is alpha divided by 2, or on the left side is going to be Z smaller than minus Z alpha. Okay, yeah, standard deviation of pool, yeah, multiply with 1 per n1 plus 1 per n2. Let's take a look examples. Yeah, this is Owens Lawn Care Incorporated manufacturers and assembles lawnmower that are shipped to dealer throughout the United States and Canada. Two different procedures have been proposed for mounting the engine on the frame of the lawnmower. Yeah. So the question is there any differences in the meantime to mount the engine on the frame of the lawnmower? The first procedure was developed by a long time Owens employee, which is Herb Wallace, and we can call it procedure 1. Yeah? And the other procedure was developed by Vice President of Owens, which is William Atkins. Yeah? So we can designate as procedure 2. To evaluate the two methods, it was decided to conduct a time and motion study. So a sample of 5 employees was timed using Wallace and then 6 using the Atkins methods. So both are under 30. Yeah? The result in minutes are shown on the right. Yeah, so the question is there any difference in the mean mounting time? Use the 0.1 significant level. So this is the data. So we follow the 5 steps. The first step, we are going to state the null and alternate hypothesis. Yeah. So as null, we are considering that there is no differences here between both of the procedures. So we can write down mu1 equal to mu2. So we have claimed that actually there is a differences. So we can write down mu1 is not equal to mu2. And then we state the level of significance. The 0.1 significant level is stated in the problem. And then we find the appropriate test statistic, which is because the population standard deviation are not known, we are going to use t-test. But in this case, the t-test must be put. Yeah. So this is the picture that we are going to have, yeah, which is two-tail. And based on the calculation, we can find that the critical value is minus 1.833 for the left one, and then the right one is minus 0.833. Where do we get this? Yeah, so we get this is coming from the table, which is in this case, because we have two variables to sample, so we are going to have degree of freedom of minus 2, yeah, and we are going to find from the alpha, which is 99, yeah, sorry, 90%, yeah, so 0.10. Okay, let's take a look at the table. Yeah, so this is the table. Okay, so from this table we can find from the distance, yeah, from the left to the right is 95, yeah, so 0.05. So this is the number that we are looking for. And then we have the number of sample is 5 plus 6, yeah, 5 plus 6, which is 11 minus 1 minus 2, yeah, so we have 9. So we have the number is, yeah, 1.833, yeah, similar with this, yeah. Okay, so 1.833. So from this we can go and then we can conclude, make the decision rule. Reject H null if t is larger than t alpha divided by 2, yeah, and degree of freedom is n1 plus n2. Okay, so we are going to input the data. Wells, and then no site as Atkin. Yeah, and we put the data 24932. Sorry, this is 2, and this one is 37584 and 3. So we have these two data already, so we want to make a comparison between both of the information. Okay, so we can still remember this is a two-tailed test with 0.10, yeah, 0.10. So we go with data analysis. Yeah, so we can go directly underneath. Yeah, you can see there is two sample for mean, two sample assuming in unequal variance, two sample assuming equal variance, and paired two sample for mean. Yeah, so which one we choose? Yeah, because this is going to be t-test. Yeah, and we are having an assumption that actually both of the population or sample are actually having equal variance. So we are going to choose this, and then we click OK. Yeah, so we choose the variable 1, which is Wells theory. Yeah, and then we choose the variable 2, which is Atkin, and then we put that there is no differences. Yeah, and then we put the label. We have 0.1 as the alpha, and we just go directly put the output here. Yeah, so make it faster. Yeah, let's check again. Yeah, variable 1, which is Wells method, variable 2, which is Atkin methods, and our hypothesis is mu1 equal to mu2. So therefore we put the hypothesis mean difference is 0, and there are labels, which is Wells and Atkins, and then the alpha is 0.1. So everything is already checked, and then click OK. Yeah, so we will have the result. Yeah, mean will be 4 for Wells. Yeah, Atkins 5. The variance will be 8.5 and 4. Now we are going to count the calculation in SPSS. First, we have to put the variable, but this different from Excel. We have to put the variable into a more uh, grouping side. So we have to group between method and time. In method, we have to use both of the data, which is at only two. Yeah, only two, which is uh, we set as nominal, and the time we are going to use interval. We input the data. So in input the data method, we can also put the values. Yeah, for 1, for example, we put Wells, and then 2 we put Atkins. So later the data input can be done by only inputting the number 1 or 2. So we put 1 for Wells and then 2 for Atkins. So you see that we have different column than Excel because SPSS think differently in analyzing the compared t-test for sample mean. Yeah, so this is the data view and this is the variable view. Okay, now we can see, the values and the data in the non-values. Yeah, okay, so we put the time, we input everything, and then now all we have to do is just click analyze and then compare means, and we take independent sample t-test. Yeah, make sure that the data already correct. Yeah, compare mean, independent sample t-test, and then we input the time in test variable and method in grouping variable. We have to define group. Group 1 is 1, Wells. Group 2 is 2, yeah, which is Atkins. And then if we took options, we took the confidence interval 90% and I think everything is okay, then click OK. So the result, the T is 0.662 minus, yeah, minus 0.662. Similar with the result by Excel. So I think that's all for today. See you in the next meeting.